Hi, everyone. So today we're going to be talking about the electromagnetic spectrum. We've been talking about electromagnetic energy, the waves and their different properties, but now let's look at the spectrum, the range of different properties. So what we call the electromagnetic spectrum is a complete range of frequencies, and their different properties are related to different types of electromagnetic energy. So we use this to gather information about distant objects, such as stars, galaxies. We can see the rate that things are moving. We can see if they're moving towards us, away from us. And we can also, based on the different frequencies that we gather, determine what different stars and galaxies are made of. So let's get into the notes. Here we have our entire electromagnetic spectrum. We can see as we move from left to right, the wavelength is getting smaller. The image here shows when we're going from right to left that the wavelength is increasing. Just the opposite, as you're going from right to left, you are going from left to right. When you go from left to right, the wavelengths are getting closer together. The energy is increasing. As you're going from right to left, we see the waves are getting farther apart and that energy is decreasing. So they have an inverse relationship. When waves are farther apart, less energy. When waves are closer together, the more energy. We know that from before. So let's talk about the different parts of the spectrum. We're going to talk about radio waves to begin with. And radio waves have the longest wavelength. Because they have the longest wavelength, they have the lowest frequency and the lowest energy of all the electromagnetic spectrum. So some examples of objects that use radio waves are different radio stations. I'm not talking about satellite radio. I'm talking about the AM and FM radio stations that you may listen to in the car or on the bus. Radar systems, we use the different radar to track objects that are moving, or also weather patterns and systems. We can tell based on how the waves are moving differently and what's happening. And stars also emit radio waves. The next is microwaves. So we use these mostly to carry data transmission. So what does that mean? Microwaves themselves use microwaves, the box. Wi-Fi routers, cell phones, all use microwaves. Now, we can't see those microwaves going through the air. However, that is how that data is being transmitted. And also stars can release microwaves from their light that's being produced. The next is infrared. Notice our waves are starting to get closer together. And infrared are just below visible light. So we know that the color with the least amount of energy is red. Infrared, just below red visible light. So again, that infra prefix means below. Some examples: remote controls use infrared waves. Flames that's being produced. So not only is it producing visible light that we could see with our eyes, but flames are also releasing infrared waves. Lamps, night vision goggles, those use infrared waves that are being released by different objects and bouncing off to see what's happening. And again, stars also give off infrared waves. Next, we have visible light. And so this is the only wavelength of light that is visible to the human eye. Roy G. Biv: red, orange, yellow, green, blue, indigo, violet, are rainbow. They're all only part of this tiny little section of the electromagnetic spectrum. So red, orange, yellow, green, blue, indigo, violet. I'll give you a moment to fill in those. Light bulbs give off visible light. We can see the light that's being emitted. Fire, we can see the light from the fire. And stars, we can see stars in the sky because of the visible light that they are giving off. After that is ultraviolet. And so violet has the most energy of Roy G. Biv. So ultra, above violet. And this is also called black light. So we use those black lights. That's ultraviolet light. Stars emit ultraviolet or UV light. This is the part of the electromagnetic spectrum that's being released from our sun that causes sunburn. So if you have too much electromagnetic energy, ultraviolet light that's being coming in contact with your skin, it can actually destroy your skin cells partially, and that is what causes sunburn. And haunted houses also use those black lights to kind of add that spooky, scary effect. Next, we have X-rays. So again, notice our wavelengths are getting closer and closer together, so our energy is increasing. And these are high-frequency waves. They're not the highest, but we use X-rays to see inside objects. It doesn't necessarily just have to maybe be bones within your arm or your body to see if something was broken. But we can also use X-ray technology to see what is inside other objects. Like maybe we found a treasure chest and we want to see what's inside. We can X-ray it and get some kind of idea. Airport security uses X-rays to see inside of luggage and your shoes and your jacket to make sure that we're all being safe. And stars, surprise, also give off X-ray waves of electromagnetic energy. And finally, we have our gamma rays. So these are the shortest wavelength, as you can see, especially compared to radio, which are so long. Because they have the shortest wavelength, we know they're the highest frequency. They're happening the most frequently. And because they're happening so often, they have the highest energy. So I like to think about the relationship between energy, frequency, wavelength is waves at the beach. Right before the storm, we can have a hyper kind of wave activity day where the waves are happening very often. They're close together, one after the other, and a lot of energy is being transferred along the way. I call those hyper waves compared to our radio waves, which are really far apart. Those are like lazy waves. They're not happening that often, not a lot of energy, low frequency. So we have our hyper, like our gamma, and lazy, like our radio waves, to know the difference. And some examples, we use these in radiation therapy to help treat cancer and other types of mutations within the human body. Sterilization. So if we are sterilizing equipment, gamma rays is one that we can use. And surprise, stars. Stars give off really every part of the electromagnetic spectrum, just in different quantities. So how do we actually use these? Well, stars were the most common thing that the electromagnetic spectrum is emitted by. And the way that we observe the light depends on the portion of the electromagnetic spectrum we want to study. Remember, electromagnetic energy and light, they're the same thing. Visible light is what we see, but any part of the electromagnetic spectrum we call light. And we have to use different instruments in order to determine these different properties because different instruments are sensitive to the different wavelengths of light. So we have some kind of satellite that's either on Earth or in space, and it can track the different types of wavelengths that are being given off. So not all light can get through the Earth's atmosphere because we have the ozone layer and the greenhouse gases, which help kind of absorb and dissipate some of those harmful levels. So we can't collect those here on Earth. So we have to have telescopes that are on the board, different satellites, so we can actually get all that information about the stars around us. All right, go back and fill in anything that you may need to that you missed, and your check-in should be posted shortly. See you later, guys.